Hello, hello. How's my audio? Is the volume okay? Do I even recognize anyone anymore? I think we're still going, yeah? All right. Nice. Good. Good to hear that. Good to hear that. Welcome, welcome. Yeah, I know every time I do a stream, I always say I'm going to not I always say I'm going to do it the next week instead of waiting another like 3 months. Sorry. Sometimes life gets in the way. How's everybody doing? Did y'all get a chance to check out the 016 release notes? Oh, you want a Japanese update? まだ毎日勉強する。まだまだです。けど、頑張ります。Yeah, I have a tutor now. It's nice to practice. It's good. Slow going, but it's good to good to be an American that has a second language, right? Justice, good to see you. Last time I saw you in person was in Nuremberg. Wait, that's the English way of saying Nuremberg is super weird compared to how it's actually pronounced, right? What is it really? It's like oh, I forget. Okay. Well, let's get started. So today, it's been a while, so I expect we'll have some catching up to do. It's okay, we'll go slow. But welcome everyone to the old timers and the newcomers. So the primary topic that we're gonna do today is we're going to look at a branch that I've been working on that makes a big change to the build system, and I'll show you what's going on so you can see what to expect. I'll show you my progress. I think it's pretty interesting, and then we'll try to make some progress on it. But anytime that you want to interrupt me and ask questions or take a little detour, feel free to make a bid for that. And then, sorry, pouring myself some tea here. All right, and then, oh, hey, Befredel. By the way, I have not forgotten about you. Look what I have right here. It's gonna happen. Just give me a second. I beat you to it. I did it before you even said that. Gotcha. Anyway, okay, this will be an ephemeral stream, so have fun. Enjoy the moment that we have together, this fleeting time on planet Earth before it passes, and well, I'll just learn to let go together of the idea of this trying to be preserved for all of humanity or whatever. Okay, so let's get started. Where should we get started? Right, okay, so let's talk about this change that I've been working on. So here's my little build environment, and I'll put it together for you again so that we can kind of start over. So here I have a terminal. I'm in my zig folder here. I have no active changes. This is the current upstream. If I pull, nothing's going to come in. I'm pretty sure. Yep. Okay, and let me give you just a little font bump, eh? How is this font size? Is this acceptable? Or do we need to go one more? Oh, I forgot to do this too. Pin. There we go. The font looks fine. Okay, good. I'll do a little intro, and then I always forget to change my setup so that it fits with the chat thing. I always got to do something like slightly different because I'm a one screen guy. Okay. Well, anyway, so here's master branch. Let's switch to build runner process. So now I'm on this other branch. Now, before I give you a tour of it, let me just briefly explain the idea here. So let's say that you are you have a build project and you have your build script here. So as we all know, your build script gets run from the build function. And what you have to do in here is you have to declaratively create these, options that can configure your build. Then you can use these options to do logic. But ultimately, what you have to do is you declaratively create these artifacts that your build system can create. And when you call these functions, it's not invoking the compiler right now. It's just creating this data structure in memory. And then eventually, this function gets to the end, and that data structure then gets executed by, well, let me actually switch to a different terminal and show you what happens. So now I did a little sleight of hand here, and I'm on a different folder. So this is master branch. I didn't switch to the other branch in this folder. This is the branch. This is master. I'm doing a little desktop switcheroo. So when your build script gets to the end and it finishes running this build function, here's what actually happens. You're actually running inside this build runner process. Here's the actual true main of the build system. And this main actually is going to call this build function. And it's right here. So it's calling this run build. Let's see if I can get you the satisfaction of actually getting the build. Yeah, so there you go. We call this run build, which is going to call this. This is what's actually calling your build function right here. And hey, look at that. You can return void, or you can return an error if you want to. Actually, I had forgotten about that. Anyway, point is, running your build script happens here. And you can see that there's code that runs before this, and there's code that runs after this. And so what the terminology that I've come up with to kind of just describe these different things is that the code that runs in here, aka your logic, I'm calling that the configure phase because it corresponds to the configure step that other build systems have, like before you actually do all the work. So I'm calling that the configure phase. And then what happens afterwards, I'm calling that the make phase. And that comes basically because all the build steps, if you look at all these steps here, for example, they all have this make function. That's kind of the implementing this interface that does the stuff. So there you go. So this is the make phase, and this is all happening inside of in the build runner after your build script runs. So the change that I have made in a branch is I have split this part and the rest of it into two different processes. So it's not doing anything funky like WebAssembly or anything like that. We're not going there yet. But what we are doing is running your build logic in a different process as we're running the build runner or the build system, the rest of the build system. And this is becoming more and more important as we have features like, which you can start to see here, like the, well, we have file system watching. Have y'all been using the watch flag and F incremental flag? Yeah. Has anyone here not tried this out yet? No shame, but okay, everyone try to convince setuid run to try it because it's good. Okay, anyway, where was I going with this? So we put right, what I was saying is it's starting to become, we're starting to add a lot of features to the build system. And so features like watch, features like the web UI. I should probably show you guys the web UI. I bet you a bunch of people here have never even looked at it. The web UI already has some nice features, and it's only going to get more. Yeah, what's the web UI? That's what I figured. And then also we have a fuzzer, and the fuzzer also has a web UI interface in it. But even if you're not using that, I mean, the fuzzer lives in the build system, and the fuzzer is getting more and more capable. So what's happening is that the build system is getting more featureful, and every time you run zig build today, you are paying the cost of all these features because you're recompiling all of these features from source every single time you run zig build and you have any changes to your build script. Furthermore, we run your build script in debug mode, obviously, which is the right way to do it. But really, we would rather run like the web UI and the fuzzer and the watch system, and also just the part where we call make in the hot path. We would rather have all that stuff be optimized, right? Obviously. So what having the configure phase and the make phase be in different processes allows is running your code in debug mode and running the build system in release mode, probably release safe. And that way, when you make changes to your build script, you don't have to sit there and wait for the build system to get recompiled. It'll make it'll just make it really a lot faster to run zig build when you make changes to your build script. That's the whole point. Yeah. Plus the build system can run faster since it can be optimized, and then also because of the phase separation, we can also we can change what some of the things are that run. Let me just demonstrate this instead of trying to form an awkward sentence here. Okay, so here's the help menu for the build system, and you can see some of these options will require us to rerun your build script. So, for example, if you specify some of these options, your logic depends on these, so we have to rerun the build logic. However, if you've given us a build system graph, you build a declarative graph of all the steps in your builds in your project. So actually, the steps that you want to run, we don't need to rerun your build script depending on which steps you pass. But we currently have to. Yeah. So that's an example. And then more examples would be like, have you ever had to rerun with adding reference tracing, for example? You don't pass this argument, but then you end up wanting it later, and then you have to wait for the build script to recompile. Well, with build phase separation, if you add or remove these flags, we don't have to recompile anything. It can just run it again. So a bunch of these flags actually only affect the runner, or the make phase, if you will, not the configure phase. And so like a bunch of these flags, like pretty much all these flags, then we won't need to recompile anymore for this stuff. So I think you're starting to get the idea of the motivation here. Basically just making things faster. Same as usual. Okay, any questions on the overview motivation for the change before we move on to the implementation? Okay, well, let's just move on, and if I see questions, I will go to them. So what I've done in this branch, which already generally it's not feature complete, so I can't run it on the compiler itself, but it's like basically working, so we can try it out. So let me show you what I've done, which is different from the main branch. The main idea here, well, I think I should show you on the file system first what's different. Okay, so now in here we have the configurer, which is responsible for running your build script. And then we have the maker, which is does not interact with your build scripts, directly. So this one is going to run your build script, and then it's going to produce a serialized version of the build graph. And then this one is going to consume the serialized version of the build graph and like do the build stuff that the user wants them to do. So if we take a look at that, and these files are basically just like splitting up of, in the main branch, what was this file. Okay. So if we look at configure, a lot of this logic is identical to what's in this file, but it's just less stuff. It doesn't have the web UI, it doesn't have the fuzzer. It doesn't have to process nearly as many arguments. And then, most important, yeah, here's where it runs your build script. And then we have this call to serialize. And so serialize now is going to, it's going to take all the state that you constructed in your build script, and it's going to serialize it into, you guessed it, another little structure, a little horny for DoD structure, where we just try to bit pack the shit out of everything for fun. And I can show you how that works. So let me give you a little demo now. In this tab, I'm going to go to just a temporary directory. I'm going to kill my ABC here. ABC is basically my TMP inside my TMP because I'm too afraid to delete my TMP. Okay, so I'm going to use zig init here. And I've almost got this working to build it with the new stuff, but I do have to go make one edit. So I didn't get this working yet, so I'm going to comment that out. But we'll come back to that. And so you should all probably recognize this. This is just like the zig init thing, you know. And right, how do I build this branch? Okay, right. So in order to build this branch, actually, if you wanted to follow along at home, first you have to build master branch and produce, and you have to bootstrap, and that gives you this binary here. But the problem is on this branch, I can't use, I can't do this because, well, yeah, this binary is expecting the old build system, but we deleted the old build system because we have the new build system there, or we have the new, like, you know, way of doing it. So what you have to do is you have to end up doing like a build exe command directly, and that will work in this branch because we're avoiding the build system. And then so then I made that file output to here, zig safe. So that's the binary that we can use to test this branch. And so, right. Okay. Yeah. And then, so here I'm going to run the build from the branch in this little directory here. So now you can see we're compiling the configure script and the maker script at the same time. A little hard to see, but we compiled the two things simultaneously with async await. That's kind of nice. We ran the build script, and then we collected all the user options and stuff. You can see those are missing, so I think that's a to-do in this branch, but these are here, so that part worked. And then I also want to show you I added this debug maker flag. So like I said, one of the features that we would do with the phase separation is we would compile the maker in optimize mode, but obviously when we're working on it, we want to debug it. So that's why I added this debug maker flag. So we add that, and now if I just pass, this is just zig build basically. Like, don't mind this long, don't mind this long file path. This is just our like debug binary, and then I'm running zig build with debug maker. So If I run that, you can see that that didn't end up having to rerun anything. It didn't have to rerun the configure script or the maker. And then we got our thing, and there's our hello world basically. So that basically works. What else can I show you here? I think, oh yeah, I'd also added another flag called something about configuration, I think. Maybe I didn't document it yet. Oh, it's print configuration. Oh yeah, I need to add that to the usage because it's missing. Okay, we can do that in a moment. Okay, so I added this new flag called print configuration. And so what this is going to do is, well, actually, before I run this, let me just show you what's in the cache. So I don't know if you've ever looked in this directory, but now I think, okay, so this file here, I didn't bother giving it like a friendly base name. I guess I could, I don't know. But you can see that this is a 1K-ish byte file. And I mean, this is binary as shit, so it's not gonna I don't know, it's not gonna be super interesting to look at. I'll give you a little walkthrough in a minute. But anyway, point is, this file is what the so the build script was run, right? That logic created the configuration graph. This is the file. This file here is basically the serialized build graph that was produced by this build.zig when run with those options. So what that means is we can basically now run zig build without touching this code again, with using this as an input, depending on which flags you pass. So for a large subset of the build options, we can just, let me back up for a second. I'll show you this code in a moment, but if you, depending on which flags you pass, we detect that this same file is already created for that set of flags, and so we don't need to run the logic again, and we can just pass this to straight to the make process. That probably was a little bit hard to follow, so let me just show you what I mean in the implementation here. Okay, so this is the logic that runs when you run zig build. And as a reminder, this is kind of the parent process. So what this is going to do is this is going to lazily build from source the configurer and the maker, two separate processes, two separate executables. It's going to then determine whether the configurer needs to be rerun, and then it's going to take the output of the configurer and pass it to the maker. Or it might get a cache hit on the configuration and skip the first step. Right, okay, so to give you just a little walkthrough of what this is doing, we're simultaneously constructing two argvs because we're going to spawn two processes potentially. So one for the configure, one for the make. And some stuff we're going to pass to both. So here you can see we're adding, we're going to give the path to the zig compiler to both. Well, yeah, we're doing it to configure, we're doing it to make. We're going to give the zig libdir to both of them. We're going to give the build root to both of them, so on, so on. We're going to give the same random seed to both of them. I'm not sure that actually matters, but sorry, we're only giving the random seed to the make one. I misspoke. Quite intentionally, the configuration script should not depend on entropy at all. It's supposed to be completely deterministic. That is important. So only the make runner gets the seed. And then as we go through some of these arguments, you can see that some of the arguments, they're all kind of handled differently. So some of them are going to affect the configurer. Some of them will affect the maker only. Some of them affect this parent process only. Some of them affect both. Yeah, it's kind of interesting. And then when we get down here, we construct the compiler. We start initializing the compiler so we can build stuff from source. And then, yeah, we create the, normally the build runner is compiled for the host target, but sometimes you can, oh, I see, yeah. So then we compile, okay, we're constructing the target. Where am I going with this? Right, okay, so here we go, io.async. So we kick off a task to compile the make runner, and we can go look at what that does in a second. But meanwhile, we move on to, yeah, we start compiling the make runner because we might need it later. And then we start fetching. So with this new system, when you're like doing your first Zig build, for example, if you end up needing to like fetch stuff and you also have a never used Zig build yet, it's gonna like compile. It's gonna start working on compiling the build system and fetching at the same time. So it's pretty fun to be able to even start using the async stuff right away. Okay, so now we're already building the maker in the meantime, but now we keep going, and we start doing the fetching. Oh, hey Frank, good to see you here. We start doing we start doing the fetching, and then at some point this one's gonna come back. We await that one, and then okay, well, this code's not new. This is all old code. So okay, finally the fetching's done, and we needed that to be done before we run the configure script, because the configure script might depend on the fetched packages unless they're lazy, and that's what's going to be handled right here. So we build the configurer from source. You know what I just realized? We can do more in parallel here, because no, we couldn't. We actually need to compile the configurer after the fetch, because you can literally just do @import on your non-lazy dependencies. So we do have to wait for non-lazy dependencies in order to even compile the configure script. Okay, so then we do the compilation. We figure out where to store the configuration that we just generated, which I was showing you here. Okay, and then we check if it's a cache hit, because wait, I think I might be missing something here. Is there a second cache check here? Let me make sure I'm saying the right words here. Yeah, okay, so we still have to compile the configurer. That's right. We still need to build the configurer from source to the configure runner to make sure that before we can check for a cache hit. But if it is a cache hit, then we don't have to run the build logic. That's the difference. Because maybe a change in your dependencies caused the configure binary to be different. That's why we have to care about that. So, like for example, we don't want a false cache hit if you go make a change to your build manifest file, for example. Okay, but what we can do is if we get a cache hit on this configuration, we can avoid rerunning the build script. You wouldn't do something non-deterministic in your build script, would you? Okay, so then once we decide we have to run the configure script, and keep in mind this whole time we've been building the build system, which may or may not have finished by now, right? Okay, so finally we get the information. All right, this part's kind of cool. So now now remember, we're in the zig parent process here. We just finished running your build script. We just finished running the configure process. And now it loads this configuration from disk, this thing I was just showing you here, this like cached configuration build graph. Why are we doing this in the parent process, right? Because I just told you we only need it for the make runner. So, but why are we also loading it in the zig parent process? Well, it's for fetching. So this configuration also tells us about the dependencies that need to be fetched that were lazy. And so because we created this nice little binary serialized thing that's super easy to load, this was also a really handy way for the configure runner to tell the parent process about which dependencies need to be fetched that are not lazy, or they're lazy so they weren't fetched, but now they need to be fetched. Okay, so if we have to go fetch stuff, we add to the hash map that says which steps are not lazy, and then we repeat the fetch process, and that requires us to actually recompile the configure again. And so you can see this process where your configure script might need to be rerun several times. It might need to be recompiled several times as it learns by running the script that dependencies which were lazy actually do need to be fetched. And so it's important that we can compile the build script quickly, and by keeping the make stuff out of that process, out of that executable, we can keep the compile times down on that build script. Okay, so moving on, and again, we're in the zig build subcommand logic here. So moving on, let's say we finish this process. We basically, and we save into the cache the file. So for next time, we can hopefully get a hit on this, cache hit. Okay, so once we make it out of this loop, we got all the dependencies, and we ran the configure script, and we got the configuration file like finished. So that means we're finally ready to run the make runner. So now, only after doing all of that work, now we do await right here on the task that we kicked off before all this fetching stuff. So cool, now we have the make runner, and now we can spawn the make runner. So we now can simply just we can simply do a process spawn. We already constructed the argv, and we just pass it right here. We're just passing right here. We're just passing the configuration file, the path to this serialized data that we created. Okay, I don't know how easy that was to follow, but that's the overview of how the zig build subcommand is working. Anyone? I'm gonna pause for a second and have a couple sips of tea and give a chance for people to do some QA if they want to, and then I'll move on to showing you some more stuff. Hey, two-step, long time no see. Wait, I feel like I just learned recently that I know you under a different name on like Codeberg or in person or something. What's your name again? Well, if you don't want to share it, that's okay. Case faults. I'm not sure I recognize that actually. Question: is it possible to detect if configure is non-deterministic? Well, okay. At the end of the day, it is arbitrary code execution. So you could just do something non-deterministic in there, but the build system is going to behave horribly if you do that. Like, this whole system is designed to assume that you do not do something non-deterministic. And you will have to try. Like, I don't think you're going to do something non-deterministic on accident. It would be pretty weird to do, like if random number 1 out of 10 is 5, then create an executable, otherwise create a static library. Like, who's going to do that, right? But stuff you got to be careful about would be like, depending on the current time, it's no good. That's you should always, You should always take the current time as a input. You should never check the time in your configure script, stuff like that. Yeah, I have a feeling, it's not really possible to fully prevent users from doing this, but the system will not work properly if you, you're going to be fighting an uphill battle to try to break this rule. And I think it won't be, I don't think it will be challenging to avoid this on accident. Does this branch move configured to awesome? No, this is not WebAssembly, nothing WebAssembly related. This is just two separate processes. It's just a serialization of the build graph and deserialization of the build graph. Does configure do anything besides yield the serialized graph? Or is that the primary job? No, that is the primary job. I'll give you... We looked at it briefly before, but I'll pull it up just one more time here. So this file is just north of 1,000 lines. The main function is about 200 lines. You can see it's basically just processing arguments and then calling serialize. And that's pretty much all it's doing, right? Process arguments, serialize. And then the rest of the code is just serialize. And I'm going to show you a little bit more about this because I think that's part of the fun of this branch too. Did someone kidnap Andrew? I don't get it. Are you expecting me to have red hair or something? Are the proposed types, Vec2, Vec3, Vec4 types, only going to be good for shader programming, or will they be amenable to general purpose application and game programming as well? I'm expecting these to be general purpose. So they will work on all the targets. Other programming languages like C don't do this. So like, for example, 128-bit integers are only available on some targets sometimes, or like 128-bit floating points are only available sometimes, and sometimes long doubles of 64-bit, or sometimes it's 128 or whatever. In Zig, you get all the types on every system, and if a system doesn't support that type, you get it anyway with a runtime library, which C already does anyway. It just does a really shitty job at being complete. It's just arbitrary which operations you get and which ones you don't. You don't get shims for, but in Zig you always get all of them. So part of the reason that I think Zig will be really handy to use for Spear V targets or for shaders is sharing code and sharing data layouts across the CPU and the GPU, because more and more modern GPU programming is not based on a fixed function pipeline. It's based on sharing buffers. So you create your buffer on the CPU side, you give the buffer to the GPU, and then you do something with that buffer on the GPU side. Or in a lot of cases, like on these like nice Mac hardwares like M1 and beyond, it's the same memory. Like the CPU buffer and the GPU buffer are the same buffer, which is really nice. And so, of course, why wouldn't you want to have the same code running on the CPU and running on the GPU if it's the same memory layout? So I think part of the big benefit that Zig is going to have for shaders is giving you both the type safety, but also the control, like pack structs, non-exhaustive enums, just fucking methods and namespaces is so nice. I think all these things are really, really valuable when doing this kind of programming. So yeah, I'm looking forward to getting in deep on shader programming with Zig. I think it's a good use case. Errors? I don't know about errors with shaders. It seems like you should just avoid errors with shaders, honestly. Ban syscalls and configure. Yeah, I mean it is possible. Like one of the possibilities could be like, yeah, targeting something like WebAssembly and configure, but I don't know. One step at a time. I think that it's I think people will probably have to make some adjustments with this when this change lands, but it won't be too bad. I think mostly everything will basically work the same. But we'll see. So we can evaluate a further step later. Yeah, sorry, two-step. You came in a bit late. So basically, we're working on the build phase separation. I did like the whole part that you missed was me going over it, so I don't want to repeat that. But um, basically, the code in a sentence, the code that runs in your build.zig script in a separate process than the rest of the code that's running the build. Question: what was the seed for? The seed is used in the maker process. Right. Okay, so the maker process wants a random seed for a couple reasons. One of the reasons is this. So if you're supposed to create a build graph, and if you miss a dependency edge between steps, that's like an invalid configuration. But if you get lucky or unlucky, depending on how you perceive it, you might not learn that dependency edge is missing. Because it might just so happen that other step gets completed in the right order, so that it doesn't get messed up. So what this shuffle does is it has a chance of finding a missed dependency edge. You try a few different runs, and at some point you're going to learn, oh crap, my steps are missing a dependency edge, and then you fix it, and then the problem goes away. But you also want repeatability, so that's why we have a seed. So if you pass in the same seed, you're going to get the same step order, so you can repeat an issue. Like, for example, if literally that exact problem happens where you discover you're missing a dependency edge, you can then repeat the problematic order by using the same seed, and deterministically always get the crash to debug it. So it's a good pattern. Sometimes you randomize stuff to catch problems, but then you also want to be able to repeat it. So you always want to use a seed to control your entropy. Technically, it makes everything deterministic, right? If you always pass a seed. What's DoD? Sorry, I used an acronym without explaining it. Data-oriented design. Yeah, that's it. I assume this means no more custom build steps. You are correct. This is why I have been saying please don't use custom build steps. I think it's at this point custom build steps have become even more problematic because there's all these things you got to do correctly in the build steps. Like you got to register your dependencies, you got to register your watch file inputs, you got to use the cache system correctly, you got to report errors correctly. There's a lot of ways to like mess up. To just do something wrong in a custom step, and instead you can just make a run step, run arbitrary zig code with the main function, and then it'll handle everything correctly for you. So that's what you're going to want to do, and that works fine with this phase separation actually. So yep, that's what people will have to give up, and I've been warning people about it for a while because I knew I wanted to make this change. Yeah. Are the configure make names set in stone? No, they're not. Feel free to bike shed that a bit here if you want. I've seen some alternate suggestions. Yeah, feel free to make an argument. Have I thought about streaming on YouTube instead of Twitch? I don't know why. What's the difference? They're both just some shitty big corporation. If I was going to switch my streaming platform, I would probably try to look into some like FOSS thing where it's like you can only watch it while it's running and then it's just gone when it's gone or something like that. I'm just so tired of all these big corps just being super hostile to everybody. What's my stance on a batteries included? You can stream using FFmpeg? Dang, that might be the move. Holy shit. All right. What's my stance on a batteries included standard library? Something more towards the end. Honestly, haven't decided on this yet. So the roadmap looks like. Well, let me just pull up the roadmap, shall I? All right. By the way, I wish this went without saying, but this is all created by hand. All this whole page. So if you're interested in Zig, please enjoy these handmade words. Where am I going with this roadmap? Yeah, in the past, putting these release notes together has been kind of challenging because I kind of went through each commit one by one and saved all the work to the end. But we've been using a system now where we try to stay on top of typing up the release notes more or less like as the pull requests come in, and we use like labels to like bookmark which ones are important to include. And I think as a result, it's been higher quality release notes. And yeah, I think these in particular are like the best quality release notes that we've written so far. Like it took about a week to do them. I think it was worth it though. But anyway, so roadmap 017 is going to come out like pretty soon actually. We're right in the middle of upgrading the LVM 22. I think there's just like one more weird thing happening we got to figure out. And then, well, here's the thing I'm talking about on the stream right now. Why was I bringing this up? Oh yeah, this is what I'm responding to. So I think completing and stabilizing the language is still kind of the next step towards 1.0. These are kind of like tool chain things that we need to do. And so my point is that first we finish the language and we try to be done. Like no more changes, unless we like realize there's a problem. Next, we go through and audit the standard library and like clean up, just get stuff out of there that's not needed. Make sure that the APIs that are there are like well tested, named properly, documented properly, all that stuff. Then I think one of the final phases before 1.0 is asking the question, what's missing? Like, what do we need to put in the standard library, even though nothing in the Zig project itself depends on it? And I think that will be like when we start adding stuff that's not strictly necessary to the standard library, you'll know that we're in like the final phases of reaching 1.0 basically. Although, I mean, honestly, that doesn't have to block 1.0. Like, we could do 1.0 with a minimal standard library, and then adding stuff doesn't require making breaking changes. However, adding stuff might inform that we would want to do breaking changes. So, I don't know. That's the trade-off. Okay, let's move on a little bit. Feel free to keep asking questions, and you can repeat if you want, if I didn't get to you. But I'm just gonna move on a bit. Okay, so we talked about motivations. I overviewed the implementation on the CLI of Zig build. So now I'm going to show you in configure. I'm going to show you the serialization strategy. So I showed you that we're serializing to a like fairly compact file. So the Zig init template is producing this 1K file. And in fact, let me just show the whole hex dump. So yeah, here's the whole hex dump. It's not that big. There's all the strings. That's a little sus, isn't it? What's that doing there? That looks like some undefined memory. So maybe we'll need to take a look there, but not important right now though. So how is this file produced? So in this is it's not actually a breaking change. So you'll notice that I actually just ran the real build.zig script from the init template. It's not changed. I had to comment one thing out because it's not implemented yet. But other than that, all these APIs are the same. So what we're doing is we're taking like the in-memory structure that this creates and serializing it into a file. So here's the code that does that. And it's built around this abstraction that I made called configuration. And you'll see that I put it in the standard library. So you all can have access to this in like tooling that you make. Like, for example, if you are the ZLS team, you probably are very interested in parsing this file using this API, and then you won't need to have a custom build runner anymore. Curious to see if anyone from the ZLS team has any feedback on that, but we can talk more about that later. Okay, so this configuration abstraction, if you've watched my my DoD talk, I think people probably seen this. Let's see, this one. I think a lot of people have probably seen this, but I've still been doing this technique that I outlined in this talk, and oh, hey Techatrix, you've been crying? Aw. But don't you want the don't you want this juicy file though? It's so nice. For those not in the know, Techatrix is, I think, the lead ZLS programmer right now, right? Is that true? Okay, anyway, so in this file, I took some of these. I've been, after I did this talk, I kept refining this technique, and I'm still doing like a version of it. Oh, hey Casey Banner. I'm still doing a version of this this technique, but I've been adding more and more like type safety to it and more tricks, and so I think I took it to an interesting place in this branch because where am I trying to go with this? Yeah, basically let me contrast this with ZIR. So in the Zig compiler, here's another instance of this pattern, and you can see that there's this thing that we do where what the fuck is this stuff? Okay, here it is. Yeah. So all these structs kind of represent like data that's going to be in some array or something. And you can see that I do this thing where I say like trailing, blah, 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 trailing, blah, 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 blah. Because what's happening is that like this part is always present, but depending on something else, there may or may not be a variable number of this trailing data. So it's kind of like the type, like the type system is just not having a way to represent like the possible, the fact that there's like many or one like optional or stuff that may or may not be in the struct. So this stuff, basically anything in trailing is like just not handled by the type system, but it's still in the data. So I've solved that problem like actually completely in this branch, not for that part of the compiler, but for this new code. And so let me see if I can find a good example. So for example, this is all of the data, all that represents like how you can configure a compilation step. So like literally everything in like everything you can possibly do in here. You can see this struct is like a bunch of state. You know, when you call like add executable, you get one of these, and then you can do all these weird things to configure it. You know, like this is the data structure in your build script, right? When we serialize it, it becomes like very compact, and it becomes just this. And so all of this data is going to go into an array of like U32s, and so each field is like a 32-bit integer of some kind, with some interesting like caveats with these. So for example, these flags are all just like packed structs that are 32-bit in size. So basically, this is just like all the booleans. Here we have a 32-bit integer pointing to the root module. Here we have a 32-bit integer pointing to a string. And now's where it gets interesting. So there's now after this field, we have this like filters thing. And so in the file, like in here, you will have flag length prefix list. We pass in this field here. We say which flag it is. And then we say what's the type of the element. So what this is actually doing is it's getting the value from flags, which is, we have to go down a bit. Yeah, it's getting this Boolean to determine whether there's 0 or non-zero filters. Then if there's non-zero, the next thing is an integer saying how many there are. And then if it's non-zero, then there's that many integers, which is each a string. So point being, it's very compact because if there's no filters, then simply the flag here is 0 and the data is not present. And then like similarly, there's these optionals. Flag optional is a common one. So like inside flags 4, there's a field called linker script. So inside here, there's 1 bit. And if that bit is 1, then here there will be this integer. Otherwise, there won't. Anyway, so yeah, like why bother doing all this stuff? Well, because I could actually I could pull this abstraction out. It doesn't have to be just for this thing, because we use this pattern in like 6 or 7 different places in the compiler. And so this could just be used to make everything like more type safe and also like easier to maintain, and like a bunch of optimizations that we just didn't do because they'd be a pain in the ass. And now they're just like kind of easy to do. So that's been pretty fun to play with. Yeah, this might be the most I've ever abused comp time stuff personally, but I don't know, it's working. And then so part of also what's nice about this is what I almost teased and didn't actually end up doing, but I'll do it now. So I already showed running I already showed running like build, and then that produced our zig out stuff. But there's also this new thing called print configuration. And so we can actually just dump that file, which I was just showing you, and it's this file. So we load it, and then we just dump it to Zon. And what's nice about this is that the I think it's this file. Yeah, the code that converts the binary like configuration file to Zon, producing this, is like less than 400 lines of code. Oh, and most of it's just a usage thing here. So if I skip that one, it's just like 180 lines of logic, because we can use this type information to automatically like do this kind of serialization. So this is the new feature that you don't have now, which you can now have after this branch, is like you can get a textual representation of what your build script created. So here we can see that the build script has the default step of this one. The top level steps are these. We can get more information about the steps, which ones they depend on. That can help you if you're trying to debug. Yeah, so I mean, already this has paid me dividends in this branch. When I try to debug stuff not working, I was able to just look at this textual output and understand what the data was at various steps. And I'm missing some implementations here, but okay. So I think I basically showed off everything in this branch. How much time did I kill? Good God, I wasted an hour just explaining stuff. Well, that's probably good, actually. Mm. Let me take a little moment to rest my voice, and then we can move on to trying to like make an enhancement. Any chance to see more ergonomic any type as a comp time explicit definition? Man, I'm sorry, I don't even know how to like grammatically parse what you're saying. Hi, what do you develop on? T mostly. I don't get it. Is it comp time? If you want to ask a more specific question, I'd be happy to answer. On a scale of 0 to 10, how much do you hate multi-compile unit zig code bases? That's fine. To each their own, you know. I'm not gonna kink shame. Okay, I'll answer your question like for myself. So, like for my personal projects, I'm aiming for like 100% static, all zig, so 10. But for other people's projects, I don't know, do whatever you want. Is this like an AI comment or something? Like, why is it the same? Oh, they think that this is a serious question. This is a bad idea. Sorry. Hello, welcome. Whatever static all zig but multiple zig compile. Why would you do that? I just don't understand. I'm sorry, Four-Leaf Loser. Let me take your question more seriously. What you're describing is offering a you're making it easier for what are you doing? I'm just really having a hard time taking this idea seriously because what we have now is a small group of a focused team working together to try to make the best language possible who do not need to be compromised by such things. And then what you're describing would be, I don't know, a bid to try to get more recurring income for an additional person on the team in exchange for loosening up the proposals. I don't know. I think it's just the wrong move. I guess I don't have a really good way to explain why I don't like it, but I just really don't like it. And I'm sorry, I didn't realize this was a serious idea. Aren't the storage types wasting space when you don't have the flag set? Like, unlike trailing data. No, because the flag is so let me show you what this actually returns. So let's look at flag optional, for example. Okay, I think I see what you're saying. So the actual type here is an optional. So when we interact with this struct, we are getting a convenience type where all of these fields are populated. Likewise, and that's the type we're going to use to like get a value out, and that's the type we're going to use to put a value in. But this is not the struct that we use for long-term storage itself. This is kind of like an ephemeral struct. So again, the struct lives in like the function prototype boundary. It doesn't live anywhere else. So in order to put stuff in, I use the struct. In order to get stuff out, I use the struct. But once we put stuff in, it goes into a compact form. And when we get stuff out, we use it and we throw the struct in the garbage. Does that make sense? So it's kind of like decompressed, basically. Like this struct is like the decompressed version of this stuff. Yeah. Do you have plan to have a stable ABI for Zig? Obviously, we have CABI, but directly sharing Zig DLLs and opening them at runtime would be nice. There wouldn't be a need to wrap them in C API so they would work. There is not a current plan for that. Have you ever gave a look into ziglang exercises? I'm completely new and have no idea about the exercises quality, but it's a pretty popular repo in Coburg. Yeah, those are really great. Everyone loves those exercises and report success in getting ramped up on the language. And when I'm doing Zig Day meetups and there's new Zig beginners, I always try to hook them up. Like after they get Zig installed, I direct them to Ziglangs to get started, and they usually are pretty happy with that. Are you still doing donor bounties? If someone wants to do one, they can email us. It's like probably our least favorite way of raising money, but we'll basically we do them to appease people who want them. So if you need to be appeased, let me know. So far, every time I try incremental, I get burned a bit by miscomps. I don't know if I have enough time to narrow them down. I see. Well, try again on 0.16. There's been a lot of bug fixes. And then try again on 0.17. There's also been bug fixes since then. So another thing to look out for would be when we get fuzz coverage for it. I think that's going to help a lot. We're getting there. We have a AST Smith now. So it's just like a couple more steps until we can automatically produce incremental test cases. This does not support arrays in the struct. It does. So for example, flag length prefixed list. This is an array. This one is going to be represented with a slice. So when you're putting stuff in, you have to have the slice stored somewhere else, and you reference it. And when you're getting stuff out, it directly references the data because the data is in an array in memory, so that's okay. KCBI did something pretty similar. Nice. I'll take a look at this later. Okay. So I think it's time to move on to the let's try to do something with this branch phase. Yeah. So let's keep this code open. This is going to be our testing area. Don't need this one anymore. Okay, so I showed you running build. It worked. But what if we try to do run? Okay, well, we hit it to do. Would you look at that? So let's see if we can't address this to do. We see where it is. It's in maker step run 136. So let's go take a look at there. Okay, well there it is. So we're in the make function of run. We're trying to handle different kinds of arguments, and we're failing to handle an artifact argument, which is artifact is like something that the compiler produced. So we're trying to run an executable that was produced by the compiler, and we were able to get all this data, but what happens if we delete this? Okay, so we're recompiling the maker, but we did not have to recompile the configurer. That's kind of the point. Let me make that a little bigger, or higher up, I mean. Okay, build configuration step index does not support field access. Producer index.installed path. Right. Okay, so the nature of, and it's right here. The nature of the changes that I'm needing to make to this file is that before this logic was, I'm switching over to master branch here. So basically it's this make function here. You can see the exactly equivalent line right here, right? Artifact path, And on a master branch, it works because we are directly reaching into directly reaching into this field over here, and we're looking at its memory. But in the new way of doing it, none of this doesn't exist anymore. This is all read-only configuration data. So if we want to, basically what we need to do is 99% of the changes here is just changing it so that we're getting the data out of the configuration rather than getting it out of this other like memory structure we used to be using. However, there's also, in this case, it's like slightly a little bit more tricky, because what this is doing is kind of sus already. And I was thinking about fixing it along with this branch, but I think I'm going to just keep the behavior the same. But then I should probably open an issue to change it later. So what this is doing is when you run a artifact, if you have already installed that artifact, it will run from the installation path. But if you don't, it will run from the cache. It's pretty subtle, but could be an important difference. And I think it's a little too magic. So I think what it should do instead, and let me show you from the perspective of the build script. So basically, like, because okay, I'm going to demonstrate this a little bit more clearly, actually. I'm switching over to master branch so I can show you. And I'm going to, we're going to make an XYZ thing. We're going to do zig init. I'm going to edit main. We're going to change it to just print okay, does this work? Okay, so you can see that the binary ran from the installation path. However, if I were to remove this install artifact here, it still works, but now it's being run from the cache. And that's pretty subtle, isn't it? But it can be important where you run from, because maybe like in here you also have some, I don't know, like game assets or something that you need, or a DLL or whatever. So I think it would be better if it was, instead of this affecting where the run step runs from, I think that this should create an install step. And then you should have to be like install step dot get like file abc or something like that dot add run, or I don't know, something like this. Like I think you gotta make the, I think you gotta make it part of that instead of this way. But my point is that I'm not going to change that on this branch. I'm going to leave it how it is. So, you know, let's do like let's be careful like how much we break everyone's code at the same time, you know? That's why I always tell people they should upgrade to the next version of Zig before they upgrade to the +2 versions of Zig. Just gotta go one release notes page at a time, you know? Okay. So what that means is I think I need to restore this installed path field on the compile step. And it's okay, we still have everything can be ported over like pretty directly. So I think I can just add that field back to here. So this is again in master branch. Let's just grab that back. I'll add that here. I'm going to document this field because it's kind of weird, isn't it? So when does this change? It's almost like I searched this before. Aha, so in install artifact, we mutate it. So we're going to need to do that in install artifact also here. Did we update this yet? I don't even know if this compiles yet. It must, right? Because we already saw, we've already tried the, we already did zig build and it created the binary. So I think we did do this. So let's just double check where this line is actually. Hello, Solmain. Welcome. What is the largest zig code base right now in the wild? Is it zig stdlib or tiger beetle? I don't know. I can tell you that zig compiler, if you include the standard library bits that we use, is about 1 million lines of code. Okay, so this is if it's, yes, I think I remember deleting this logic. Destdir. Oh yeah, Casey Banner's here, I think, maybe still. But I had a little trouble doing the git conflict resolution for this thing. So one of my to-dos is restoring those changes in the branch before merging. Or I don't know, maybe maybe you get the linker stuff done before. Oh, nice. Okay, yeah. Well, if you land that, then I don't even have to do that. Great. Okay. Well, it's a race then, and if I win the race, I have to suffer more pain. Bun might have more lines of code than Tiger Beetle. I think that's the case, yeah. Bun is largely a C++ project, though, right? Like, it's got a bunch of C++ dependencies. I think Tiger Beetle has no dependencies. I don't know. I don't know if you're counting dependencies or not. Install artifacts. Okay, what am I doing here? Binder.value. I'm feeling a little confused because I was expecting this code to be a little bit more like of a bijection with this code. This is master branch. This is branch we're working on. Okay, implib. Okay, clearly that's here. What is this binder thing? Is that this one? Destdir. Generated bin. I think it is this one. Yeah. Install symlinks. Okay, yeah. Full dest path. Get install path. Resolve installer. Yeah, okay. I think this code is supposed to correspond to this code. Yeah, there's this is corresponding to this. This is corresponding to this. Okay. So let me now go back to here, try to understand what's going on here. So producer index is the index of the compile step. So yeah, here we're saying producer is compile. How much does clock say the zig compiler is if you include? I think you have to include circ lib/compiler and lib/std/zig, because we just straight up have like some of the compiler in std.zig. Hello, hello. Is there anything planned, queued, with regards to the self-hosted linker? Yeah, I think that's going to be one of the most important, most pressing toolchain changes after 0.17. 0.17 should be like pretty soon, like just a week or two away, I think. And then, yeah, because once we get those linkers out of the way, we're pretty much LLVM free. Okay, so producer is a compile step. It's a little verbose here, but basically where we previously just had only one thing in memory. Now we have the like configuration version of it, which is this immutable configuration data, and we have like a compile step in there. But then we also have the equivalent mutable state version of that, where it's that thing, but we're messing with it in memory because we're building it right now. So like this one, the one in configuration doesn't change. This one does change, but there's kind of like an index which is talking about both of them. So that's what this is. And then I think this one is talking about this one here. No. This one's talking about configuration. Do I have a what's it called? A convention for this? A convention. Yeah, so step by index is the convention to get the mutable memory. And then we probably still have to cast that, I'm guessing. Let's do that. Okay, I think I want a new window for this so I can use my switch tab button. Do we use cast? No. How do we get the... Oh, it's a tagged union. It's extended. Right. Yeah. Right, okay, so here's... No, that's still the configuration. Like, damn it. Okay. I haven't picked up this branch in a minute, so it's just taking me a while to get caught up here. Yeah, so this is the immutable configuration. And we're going to need to go step by index in order to get this data, which we do need. So let's do that. Okay. And that's the parent. And now now I want to get the child. So I think I want extended dot compile. Yeah. do I have no examples of this? Oh, because it's already passed in here. I see. So the example would actually be in maker. No, it would be in here. Yeah. So we're gonna have a switch. Oh, here it is. Okay, it's an inline else. Then we call make. We're switching on it. Okay, I see. Okay, I'm getting caught up here. Right. So first we have to get the this thingy. Producer make step, which is this one, and then we want to get this thingy, which is, because it's always a compile step. Super awkward name, but I mean that's what it is. Okay, so we get, because it's a tagged union, right? Yeah, there it is. Extended dot compile. Yeah, okay. Maybe after I rewrite this code, there'll be a more obvious way to rearrange the state, but I'm taking a disciplined approach, not breaking code here. Ooh, 1.2 mils, huh? Thanks for the kind words, Velacho. Yeah, I don't know. I think Zig might be the biggest Zig project in terms of locks, clocks, which is not a flex. It's just an interesting stat. But that is why I'm sometimes, you know, like people are like, oh man, it sucks to update all my code because of the changes. And I look at their project and it's like 1,000 lines, and I'm like, oh man, I just had to update a 1 million line code base for these changes. It took me so long. Okay, so I have this now. Do we want actually a slice? Maybe that's not what we want. That is what we did in master branch, but I think that should be probably a path. In fact, I'm gonna just gonna guess that that's what it should be. Question, might a resizable struct help simplify any of the serialization going on? I saw a helper, something like slice field, that remind me of it. Those 1 million lines sure get compiled fast. Oops, I read two messages together. I'm not sure I understand the question, because I mean that's kind of what these helpers are doing. Are you talking about a language change, or like, I'm not sure exactly what the suggestion is. But yeah, to show the compilation speed, I think that actually would be, because I think we saw some people here didn't try incremental yet, right? So let me just show that off real quick. So here's Zig. We just learned from Soapston that this is a 1.2 million line code base. So let's go ahead and build it from source. So I'm gonna do, I think I want, I think I want this one. So I'm skipping like the language reference and about some other stuff. I'm turning on these two. I'm not passing no bin. I am making a bin. Okay, so first build, I'm gonna expect this to take like 12, 13 seconds, I think. although it feels longer than that by now. Okay, I didn't give us a little time for that, but that was building the compiler from source. And yeah, I mean, that included all of our backends, the package fetching, TLS implementation. I mean, it's all in there. So, all right, and then let's go make a change. What kind of change should I make? Okay, you want to start with something easy, because I want to prove that it's going to work. So, so if we run, actually, okay, so let's start with something easy, then we'll go harder. So there's the output of that. Let's go make a change. All right, done. It recompiled. How come it didn't say how long it took? Oh well. But there you go. Just like that. That's too easy though, right? Let's do something harder. So, actually, I don't like that. That changes. It's just the vibes are off on that one. Okay, it's already done. What if I delete this? Oh, that actually worked. Oh, it's just dead. Oh, I can just delete that then. Nice. All right, what if I delete this? Okay, that caused a compile error. Let's put it back. Okay, we're good. Let's do something harder. Let's go fuck up array list. Array list is used everywhere, right? So I'm gonna change append to add one and print I am a chicken. Okay, that took, you know, almost a second, but it's done. Let's undo that. Okay, it's done. I thought summary all was the default of, or summary changes was the default of incremental. Oh well. I think that default changed recently. We don't want summary all. There's too many helps in there. I thought when you do incremental, the default was. Oh, I see. The summary was like new. Yeah, this one. I thought for sure it had like timing in there and everything. I don't know. When did that change? I don't even remember that. It'd be nice if it cleared the screen. Oh yeah, okay, let's try another feature too, because I actually have never tried this before. Do we want verbose clear or minimal clear? Default is verbose clear. I think we want verbose clear. Ah. It's still not doing it. I don't know. Well, there's the clear. Okay, so that feature has been given. Well, this is a mystery that does not need solved. Anyway, I think I proved the point. Fair enough. That if you're not taking advantage of watch incremental, give it a shot. It's not the default yet. Summary new used to be the default though. That's what I'm saying. I think summary new is a fantastic default for incremental. Oh, there we go. That's what I'm used to seeing. Yeah. Why did that not be the default anymore? Okay. Anyway, so let's. There's your clear and there's your summary new. So let me just do that again. Then together we send the. Together we discover what happened to the now. Okay, there we go. 110 milliseconds. Yep. Will overriding the maker script be a supported use case? Yeah, because you could override the build script before. I think that the use case is not needed anymore, but I'm not against it if someone needs it. Do you think you still want to do it? I mean, why not? Let the user do whatever they want. Like, you can always just patch it if you want to, but yeah, I mean, that seems like a fine use case. Yeah, I guess my answer is yes. Why not? And also, why? But anyway, okay, so let's go back and do that array list change again. This is a bigger flex than I thought it would be. I really thought this would take longer to recompile. That's pretty damn good for changing array list append. That affects a lot of code. But anyway, so what's my point? My point is, yeah, try out watch incremental. If you haven't, it can save you a lot of time, even on a 1,000,000-line code base. And however, it's not the default yet because there's still problems, particularly with the linker. They're not quite where we need them to be yet, so that's why it's not default. So you might not be able to use it. Like maybe it has a problem with like some object files or shared libraries you're using or something. In which case, like, sorry, we're working on it. We'll get there, and then everyone will be able to enjoy this, including if you're linking a bunch of C code or whatever. We'll get there. But if you have a project where this would work and you're not using it, man, you're just robbing yourself of time at this point. It's super nice. Don't forget to mention that it works with LLVM backend, but only for Sema. Yeah, it also works with LLVM now. Let me try that actually. So, what do we have here? Yeah, this is fine. So I'm gonna also do use LLVM, which makes it use the LLVM backend. And I think this should work. So what I'm expecting to happen here is this part's going to take roughly the same amount of time. But then we're going to have this like LLVM emit object step, which is going to take ages. And then when we make changes, we'll get like compile errors quickly. But then like if it gets to the end of and it's going to make an executable, then obviously we're going to have to wait for LLVM again. Yeah, okay, so we made it to LLVM emit object. This part will take like, I don't know, 30 seconds or something. Zealous cares about more than just the build graph. Build on save requires the build runner to inject itself into the make phase to send out error bundles. Right, of course. Okay, so yes, I understand. Yeah, what you really want would be like a meta build protocol, right? where you could where you run zig build, so you're the parent process of zig build. And then you can use a protocol to inspect. Well, you could probably just inspect the build graph yourself. That's probably easier. But then, yeah, compiler. I'm just talking about a compiler server, but it's like a multiplexing one, right? Like it's responsible for the entire build graph, and then within individual compiler steps of the build graph, there's an even more. Okay, we're on the same page. I understand. So like you can have overriding the make runner in the short term, and then in the long term, it's kind of like this, right? Yeah. I think what Matthew's missing is that the make runner still has to do stuff to create the like ZLS would need all of this code, for example. Which, I mean, I don't know, maybe that's fine. But like this code basically. Well, actually, it would need like all the code, right? It would need like all the code of all the because it wants to do the other build steps too. It's not going to only do the compile steps, so yeah. Well, anyway, okay, we were going to just briefly play with incremental compilation with LVM before we move on. So let's try doing some changes here. So I'll do the same thing so we can see how it turns out. God damn it, we didn't get the... Man, I really feel disappointed by this changed default. I want it to be... It should definitely be summary new by default with incremental on. I know it used to be. I felt so pleased with myself when I made this the default with incremental. Wait, so if you have to copy the... If you're overriding the maker script... I see, so that's not... It's less of a copy at that point and more of a fork, right? That you maintain. Or is that right? Or... Anyway, I do think it would be quite reasonable to... What's it, 615? Yeah. Okay, so this one is kind of like the compiler protocol for... yeah, the compile steps. But then there's another protocol, which is like the build system protocol, which we didn't add yet either. And that's kind of what ZLS wants to talk to, right? So maybe that one is a good one to get started on because I mean, what do you need? Like, what do you need in its injected to send out error bundles, right? So, for example, you could in this protocol, the build system protocol, you basically would be able to subscribe to like success or failure from steps. Basically, you would get like this information, but in like a binary format where you like it's useful. And if you get errors, you get the error bundle, obviously, in not this text, which then ZLS could handle that properly. So it basically just wants to subscribe to error bundles, or right, for like per each step Is there anything else you need to do with to accomplish by injecting into the make runner? Because I think supporting the use case of running zig build as a child process with the protocol for use by IDEs is like we're like pretty much there. Like it's not a lot. It's not going to take much to get that use case going, and then from there we can add more to it, like the compiler stuff where you're like querying types and renaming and all that good stuff. Like just getting the error bundles is like pretty straightforward, right? Okay, anyway, so it took a minute to compile incremental compilation with LLVM. This is a new feature in 0.16. So even though we're using LLVM, we're still doing watch incremental. So this is pretty cool. So let me just do those same changes I did before, just for fun. Together we resist the overlords from taking away our computers. Okay, see how it instantly finished checking the front end, and then it's already in LVM object, which then takes forever, but at least skips that part. But so the key thing about this though is that I'll let this finish and I'll just demo like one more thing. So next I will, I don't know, hash map, something like this. Okay, so then after this finishes, which I think will take like about a minute again, yeah. Now I'm gonna create like a compile error here. So I made this thing a bool, and assuming we call this function anywhere, it should create errors, compile errors. So now we're reanalyzing everything, and that took a while. So now we got some errors. And okay, I'm actually gonna just straight up delete the zigzen thing here. Actually, I'll make it like the wrong type. I'll go ahead and fix this. I guess that is expected to take roughly the same amount of type there. I guess we use hash maps like even more than other stuff. Let's go fuck around with, I don't know, Sema. Let's go just delete this function that someone needs. So you can see we like instantly got an error for that. If I fix it, we instantly go back to one error. And then finally, if I fix this, oh, now I created a, what did I even do? Oh, okay. Okay, now we fixed all the errors, so now it goes back to this, and now it takes a minute. So what's the point? The point is it's still useful to do incremental compilation, even if you're using LLVM, when you're doing like a big refactor, because I don't know if you've ever refactored a big code base, but sometimes you spend like, you know, many hours in a row with your code not compiling. Like you just error, and you're just doing a lot of changes. So my point is that like you're not going to be waiting for this if you have errors, so it's still worth it to use incremental compilation if you're doing a big refactor. So that can be pretty handy. So don't sleep on it. Don't sleep on incremental compilation. It can save you a lot of time. That's my point. Okay, let's go back to the topic at hand. I think we're about 2 hours in, so maybe I can get to a little checkpoint and make a commit. And I think at this point, let's try to get there, and then I wanna call it. Go take a break and do something else. Go touch some grass, you know. And by touch grass, naturally, I mean play with my new synthesizer. So it's just over there, just begging me. Come on, touch me. Turn my knobs. Press my buttons. Does F incremental still accumulate cache over time? Good question. No, that one will, um, depending on which compiler flags you use, will have multiple cache entries. But when you're just when you're in the main loop of updates where you're like you have it running, you're making code edits. The way that the compiler sees those, as far as the cache system goes, is that those are actually cache hits. So the cache system says like, cache hit. Go ahead and here's your here's your binary that from last time. But because we're in incremental mode, it doesn't just like do nothing. It then does the it does the incremental changes it needs to do with the results from last time in order to update it. I don't know if that made sense. Okay, so man, I keep getting on wild tangents. So where are we going here? Right. Okay. So all I've managed to do is just get a pointer to this guy. I do want to document this. Set by install artifact. Yeah, plus you could have installed it to more than one place. Like, this is just such a bad idea. But I'm going to keep it for now. I'm going to file an issue and deal with it later. Okay, so what we're trying to do is restore the equivalent of... Nope, that's not what I want. Equivalent of this logic. So the full dest path is dester. Okay, yeah, so install path. Okay, I think I understand the meaning of this now. So do we have a path to the compile step here? We need it. Conf, we have the conf, which is the one from the configuration. We need this one though. Okay, so we need to basically do the same little thing here to get this thingy. I think I'm going to call this make comp step and make comp. I think that's going to be a good convention. Okay. Now we want to do basically this. So we have the install artifact dot artifact, which is this thingy. Step index maker dot step by index. Okay. Okay, and then what is full dest path? This is like the path to the executable in the install directory, which I think is here. Yeah. I think I've done it. Nope, I definitely have not done it. Make comp step. And yeah, okay. Oh man, I finally started playing this game a couple weeks ago. And people had been recommending it to me for years, and I finally busted out with it. and I played it for like 2 days, and then I went on a trip for like a week to Amsterdam, and I got to Amsterdam, and all I could think of was just going home so I could play more Outer Wilds. This game has given me like a sense of like childlike wonder that I had not felt in a long time. It's so good. Yeah, a game made by space lovers for space lovers. It's so nice. I have to say though, I couldn't get into the DLC. It just didn't spark the same thing for me. Okay, where am I going? Producer, make comp. So I have a reference to this thingy. This path is now here. Okay, yeah, here we go. So basically we have this. And yeah, okay, so what we're trying to do is get that path and put it on the argv for the run step. Okay, what's this though? Generated bin. I think this is going to be wrong. How do we get this thing? Maybe we have an example of this. File path. Ah, here it is. Yes, now I remember. Or do I? Yeah, part of the problem for this. Okay, easy. Don't go into spoilers for this game. If people haven't played it, they need to go in unspoiled. You know. Oh, I should watch a speed run though. That'd be really fun to watch. I bet. Okay, man. When I was working on this branch, I was on a roll, and then it just was time to start working on the 0.16 release, and I just like begrudgingly had to shelf the branch for a few weeks. Then like, man, you know how it is when you're working on some code and you're into it, but then you have to put it away for a while, and then you come back to it, and you're like, what the fuck was I doing? I noticed Stod.io does not allow file seeking yet. You can do that with the file writer and the file reader APIs. So that's going to be this one. For example, you can see the word seek is mentioned here a bunch of times. Also file writer. Seeking is also handled here. It's buffered and seeking. It's quite lovely, actually, I think. And it's also going to abstract away positional seeking for you, which is really handy if you want to read from the same file in multiple places at once. You need to use positional reading. You can't be seeking around. If you're trying to do like parallel stuff, right? Like if you have one task reading from the file like here, and then you have another one reading from here, but it's the same file, you can't be seeking. So you need to use positional reads. But those APIs I just showed you, they're going to give you like seeking APIs that will not clobber each other. So. Okay, so what the fuck was I trying to do? Right, I need to remember how to get from this generated bin thing to a path. And I could swear I had an example. Oh wait, is this it right here? Ooh, I think this is it right here. Yeah, that's definitely it. Maker.generate. Oh, this is actually really easy, isn't it? Yeah, okay. Well, that was straightforward. Wait, what? Generated bin. Conf artifact. Producer. There, it's producer, right? Yes. There it is. Generated bin flag optional. That's the one. Dot value. Dot question mark. Yeah. Okay, I got past ASTgen. I'm going to run the compiler on this. I'm going to have a little potty break, and then I'll be right back. I think I want another window for testing so that I can... Okay, let's see what the next compiler we get to is. Even the same line. Okay, wait. Okay, one of these is a pointer and one of them is not a pointer. So, okay, well, I'll figure that out in a moment. I will be right back. Bork, potty break. See you in a sec. Okay. Yeah, these notes are a little off, aren't they? I think what's happening is that this note is pointing at this node, like it's pointing at the parent, but it should be pointing at like the left-hand side. But anyway, okay, one of them's a pointer, one of them's not, so let's take a look. Question, do you have an idea of when managed containers removed from standard library? I mean, yeah, basically with every release, they should make one step towards that. So there needs to be a release where there's both, and then one where we rename it to change the default, and then we can delete the old one. Point is, just to make upgrading the ecosystem easier, there should just be one release where one tagged zig release where both versions work. And then the problem is that the managed ones are taking the name that we want, so that means we actually need 3 steps instead of 2 steps to do the deprecation. But I don't know, sometimes it just gets deprioritized to do those changes, but we'll get there. Okay, so one of these is pointer, one of these is not a pointer. Which one's a pointer? Pointer is on the right. Okay. Why is that a pointer? It's kind of weird, isn't it? maker.generated path. Why are we returning a mutable pointer? I guess because we're... Oh, because obviously because we're trying to write to it sometimes. Like here, exactly here. Yeah, that makes sense. Oh, wait, that's not true though. That's immutable. Generate. Yeah, why are we? Yeah, see here we're just immediately referencing it. What was I thinking? I mean, I'm sure I had a good reason for it, but I don't know what it is now. Immediate dereference, immediate dereference. Oh, here it is. Yeah, okay. So here we're... Wait, I thought I looked at that file. Am I crazy? Oh, here it is. Oh. Outpath. Generated path. Wait, what's outpath? Oh. Oh, it's a different thing. Of course. Of course. Okay. Okay, I'm catching up. This should just be a deref, and then we're good. Incompatible types. Yeah. Whatever. It's technically not wrong. Okay, I'm not going to get hung up on that. We're going to move forward. What's next? So did we make it past this logic? 1, 4, 6. Okay, cool. We made it down to here. So finally, it was taking me a while, honestly, to just get this line done. It's just like trying to resume this project that I'd put down, and now I'm picking up again. So I think it should go. Part of the reason I was doing this stream is to just force me to pick this project back up, so I wouldn't let it rot. Okay, step run 146. Okay, we're expecting a string, but we found a path. Yes, of course. Okay. Yeah, so one thing I've been doing has been upgrading like absolute paths into using these. Convert path arc. Are we using this anywhere else? Okay. Convert path arc. What do we do in the other one? We don't have it. Or do we? There it is. Okay, so this is actually kind of the same definition. Pretty similar. All right, sorry. That was probably really annoying. So we want a path there, but we were giving it string. But wait, here we're giving it a string, right? Subpath equals. Oh, I understand. Okay, yeah. This is super obvious. Okay, there we go. Okay, made to the next line. 148, expected string, found cache path. No problem. Pretty sure we have... What is this? Manifest? Add file path. Okay, there we go. Upgrade. Okay, nice. We made it to. Oh, we actually got compiling, and then we hit another to do on line 177. Okay, cool. So we made it down to this one. I think that's actually a fine first stopping point. It's just a tiny little piece of progress. Nice. And we can go ahead and make a commit. I can do one more final round of QA. You can switch topics if you want. And then I'll probably just work on this some more in my own time. But let's go ahead and make a commit. So what do we do here? Yeah. So we maker restore the logic in store step.run logic for adding artifact arg when the artifact arg is added to a run step. If the artifact is installed, then the installation path is added rather than the cache artifact path. This is probably something that should change in the future, but the goal of this branch is to generally avoid breakage other than that caused by phase separation. Okay. Nice. So I think that will conclude the main topic of the stream today. And to answer this question here, this is an ephemeral stream. Will not be recorded or preserved by me other than the 1 week Twitch VOD or however long they keep it on there. But if anyone has any more QA before we go, now's your chance. And then other than that, I'm probably just going to sign off. How do you plan to implement Vec2, Vec3, Vec4? Will we be able to specify the child type? Well, let's do a little bit of work on that. So to shed some light on the question here, they're talking about this issue, which is migrated from this issue, which is vector primitives for, I mean, basically like graphics programming. And the purpose of these is to be the types that will be used when you target SpearV. So as inspiration, I want to look at what SpearV has. Let's go HTML. Let's go language capabilities. Let's go types. Ooh, Vec4. All right. Where do we talk about the types? Ooh, now we're talking. Okay. So basically, we need a way to output all these types. Maybe some of them will be done through like built-ins. Some of them will be mapped to zig types. For example, bool can just be bool, obviously. Some of these are less obvious. An vector is an ordered homogeneous collection of 2 or more scalars. Okay. Vector sizes are restrictive and dependent on the execution model. Scalar is number or Boolean. Okay. I want to know what vector sizes are possible. Matrices are also planned, by the way, to add to Zig for the same reason. We'll have to think about these later. Probably we'll do something with built-ins there. Let's see if we can't... What I'm looking for now is like, what are the rules about... Because obviously if you just read this, it seems like you can make any size vector out of any numerical type, but I think some types are probably not allowed. So I want to learn more about that. Poison, undefined, good, good. That's gonna map super well. Component type, component count. It must be at least 2. Okay, are there any other rules? Components are numbered consecutively. I wonder if they're leaving it to be implementation defined, what the limits are. Anyway, I'm sure that I will have to read this entire spec at some point, and then hopefully I'll know the answer. Oh, this is fun. Look at this. I'll keep looking a little bit, and then I'll move on to another question. Hopefully this is giving you an idea of how this question will be answered. Dependent on the execution model? Well, I'm not sure that the limit is spec'd here. So assuming that the way that it works is that the SpearV spec defines it defines it to be like kind of arbitrary, like it does here. So like here it's saying it's 2 or more scalars, and it's saying it can be, you know, kind of any number or any of these scalars, although it's now saying it's restrictive, but it's not saying what those restrictions are, unfortunately. In such case, probably it would be a built-in to create the type, and then some, depending on what you passed, if that combination is not supported by the target configuration, which probably will include the execution model, then it will just be a compile error. Like, you can't have that. Sorry, the execution model doesn't support it. Something like this. Hope that makes sense. And then you can always just create aliases, like const vec2 equals at vector2 f32, blah, 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 blah. Would the compiler protocol signal to the running executable before and after it is being updated, so it can basically do a save load cycle for runtime data, basically to allow internal types to change while serialized state remains the same, leaving hot related? Yes, and here's the issue to track for that. See if I can find it. This one. 20604. Open a communication channel between the build system and the application. So the idea here is that if the build system spawns your application, like with zig build run or something like this, you can then basically you have a pipe open where you can speak the build protocol with your application. You can, for instance, learn that there's a hot swap available, and then you can do whatever you want, and then you can send a message saying okay, hot swap me now, and then that's when it will happen. Something like this. So let's see what I wrote here, almost a year ago. The application can learn when it has been rebuilt and restart gracefully. Yep. The application can learn when a hot swap is available and then request it at an opportune moment, such as between game frames or web server requests or after you save or whatever. The application could be notified that certain assets have been freshly built and reload them. For example, perhaps the application is a web server and the static HTML file asset changes. It could send a message to connected clients telling them to reload the page. This makes watch extend into arbitrary environments with a little bit of cooperation from application developers. Of course, applications are free to simply ignore this open pipe as well, just like they can ignore stood in, stood out, etc. I know that Mason Ramelli is interested in this, and he recently has gotten some more billable hours to work on stuff. I think he's planning on addressing some of the C translation breakage that happened with 0.16. And I suspect that he will be tackling this issue as well, because I know he told me he wanted this for working on his game. So it's actually coming up pretty soon, I think, this issue. How will the short vector primitives and matrix issues relate? Yeah, I mean, it's not super clear yet. We're going to need to read the spec carefully and play with it, and we'll need to figure out the answer to this question along with the answer to the question of how to name stuff and how to excuse me, how to rename the SIMD vectors. So we're going to figure all that stuff out together. Obviously, it's all related, right? As a robotics person, arbitrary size matrices vectors are super useful. I'm sure they're occasionally needed for game dev too, but I know games tend to use more 2, 3, 4D vectors matrices. Yep. eSIM says it's implementation defined. Okay. What do you think about the ability to reference function return value address? Function return value address. Could something like that be even supported? This we finally decided, I think yesterday, to reject. There it is. It's one of the oldest issues in Zig. It's been kind of like a center topic of working on the language. It's like, can we refer to the result location of the return value before we use it? And it just has too many aliasing issues. So yeah, as of 2 days ago, here's the plan. 32009 on Codeberg. We're basically just throwing in the towel on that idea. It's just too tricky to work out. While Zig is a general programming language, what are the top 5 areas that you think Zig can thrive in? I think Zig thrives when you have a application that you want to be correct, you want to be optimal, and you want to maintain it over a long period of time. So you have a computer, you're trying to take full advantage of the hardware, you're trying to eventually find and squash all the bugs, and you're trying to keep the software alive for a long lifetime where it can serve people for over like many years. I think that's where Zig comes in. This issue is my main block aren't using watch, I think. I'm assuming you were talking about the one with the application talking to watch or whatever. I asked earlier about resizable struct and if useful to simplify serialization, but I didn't reply. There was a thought to include it in this. Oh, I know what you're talking about. I think that Tristan opened a nice pull request for that, which I haven't merged yet, but I want to get to it soon. I'm pretty sure it's the oldest open Codeberg PR. Yeah. Nope, not that one. Different one from Tristan Crumble. Is this what you're talking about? Yeah, I think this looks really good. I want to look at it a little more closely. And then I want to try updating some of the code in the standard library to use it and then merge it. Yeah, I've been sitting on this PR, but I am actually like kind of excited to get to it at some point here. Yeah. What about the result location type? That's the concept's not going away. The concept of like it's like type coercion basically. That's not going away. Would be nice to get a tool built into the compiler to find mem copies with large compile time node sizes. I think a lot of people will get surprised by this large binaries becoming stuff. Yeah, I think this is kind of like it's a lot of lower hanging fruit to get to before I think this would be the next thing I would work on. Yeah. How many more versions until 1.0? Definitely a couple at least. I know everyone's waiting for that magic tag, but I still firmly believe that there's much more value to be gained by not doing the tag yet. What I think will happen though is that over time, Zig will become like more and more stable, and like I think the stability happens gradually. So if you can think of it as having like different people might have different tolerances for instability, and like at some point you can like maybe the stability of zig will reach your tolerance equilibrium level, then you can get in, and then at some point the way I want to do it is letting it be a little bit natural. So after we have a couple of release cycles where nothing breaks naturally, then I think it will be time to tag 1.0. I don't want to tag it just kind of like, I don't want to force it. I want it to happen because there just isn't things to fix. I just noticed your Twitch description about section has linked to Gap sponsors. Oh, thank you. Where is that anyway? I haven't edited this stuff in a long time. My description? Is that like my channel description or something? Alright, I'll have to look at that in a minute. I don't even know where that is. What I am more curious about... Oh, I understand this person's question. This is not going to happen. So you're always going to have to duplicate the return type. You're going to have to calculate the return type in an expression. You're not going to be able to infer it from the function body. What I am more curious about is what kind of foot guns explicitly specifying the location of a function result might bring and why it's considered problematic. Because you're creating an alias of the return value before you return it. Discussion about adding GPU backends other than SpearV. Not really. I think SpearV is a really good place to start. That's where personally I would want to write shaders and make applications with. But everyone is welcome to talk about your use cases for other stuff in the issue tracker. So be my guest. Okay, well, I think I would like to call it there now that it's been almost 3 hours. So thank you everyone for coming to the stream. And as is tradition, I will now promise to try to stream next week and then probably not do it. But hey, you never know. So thanks for coming by, and maybe I'll see you next week. Who knows? Take care, everybody. And how do I even close the streams? I don't remember what I'm doing here.